these. So arithmetic mean, it's just the normal way of calculating a mean. I add up everything, divide by the number that I have. So if there are 100 students, I add up everybody's grade, divide by 100. That tells me the average. All the values are used. It's unique to a data set. Every data set's going to have a different mean, or it's going to be dependent on whatever values I have in there, as compared to a mode, which if I add an extra to an end, the mode doesn't change very much, which we'll get to. Or the median, I'm sorry. The sum of the deviations of the mean is 0. On the test, I'll ask you to prove to me that the deviations all added up will equal to 0. And what that means is if I have, well, I'll get to that in just a second so we can eliminate this. Calculating the sum of the values divided by the number of values, so we know how to do this. We talked about this earlier. The sigma, we're now getting to these symbols that don't really represent plugging in something, it represents a function. And the sigma means I'm adding everything up. So adding up all of the x's divided by the number in the number that I have. And this is the population means. The sample mean is going to be calculated the exact same way. But when we get into future problems, future chapters, it will make a difference whether it's the population or the sample that we're talking about. So just for you to keep that straight. So an example, I'm doing adding up the means, or adding up all the value divided by the number that I have in there, and that's my mean. When I talk about deviations from the mean, this one's a little bit harder just because the numbers are bigger, but what that means is that if I take this 195 and subtract it from 511, from 385, from 275, etc., whatever I get for those answers, if I add those up, it should equal 0. So if I have numbers 1, 2, and 3, those are grades or scores that you got. That's a 6 is added up, divided by 3, the average is 2. If I have the values 1, 2, and 3. If I subtract 2 from 1, 2 from 2, and 2 from 3, that makes 1, 0, and negative 1. 1, 0, negative 1 added up equal 0. So if I ask you on the test to show me that the deviations from the mean all equal 0. Deviations mean how much it's off. So like for the example I gave you for 1, 2, and 3, it's off negative 1, it's off positive 1, and then it's exactly the same as the mean. So we'll go into examples of that. Parameter is just the characteristics of the population that I'm studying. So my parameter might be all stat students, or it might be stat students in my class, or all college freshmen, or whatever it is. I'm setting a parameter for what those values should fall in. And the statistic is the measurable characteristic of the sample. So here is a sample. I want to make sure my sample is reflective of my population. So I gave the example last week. If I want to study if we need a new library or new parking area, I don't want to just sit outside and take surveys and ask people questions, because it's not going to grab everybody. I want to make sure I have an equal representation. If 50% of my students are freshmen, I want to make sure that 50% or around that of my sample are going to be freshmen also. If half of them are men, then half of them need to be men in my sample. Properties of the arithmetic mean, and this is what I was telling you about deviations. We talk about deviating from the mean. If the mean is 5, then it's deviating negative 1, because it's 4, negative 2 here, and then positive 3. Negative 2 plus negative 1 plus positive 3 would equal 0. Again, an example of what I mean on the test. I'll have people skip over this question, and it's such an easy question on the test. Every set of interval level and ratio level data have a mean. I can't really get a mean of how many people like a certain thing unless I have a number to it. So I'm addressing and assigning an interval or ratio level data values. All the values are included in computing the mean. So even if I have the student who didn't show up for the test and they get a 0, if my dean asks me what's the average of the first test in this class, I have to include that 0, and it drops my average. The mean is unique, and the sum of the deviations equals 0. This is just an example of what I meant by the sample mean is going to be a little bit different from the population mean. Again, same calculation, but it's going to be a different symbol. So know if that's a little bit different. Right now, it's not a big significance to you, but it's going to be in future chapters. So here again, I have the sigma of x, so the sum of all the x's divided by the n. Here's an example of sample Same calculations, adding them all up, dividing by 12. The weighted mean is a little different, and in theory you can do it the exact same way as the regular arithmetic mean, but this kind of adds some shortcuts. So here I'm talking about the weight of 1 times whatever the value is, the weight of 2, etc. So let's go to example. I have a construction company that pays hourly employees 3 different wages. Now if I add this up, somebody grab a calculator. If I add this up and say our employees make $16, $15, $19, and $25 an hour, what's the average here? Anybody have a calculator out? I guess I can do it. Let's see. 18.67. I mean, it's about, I think it's like 18-ish somewhere. Okay, it's about $18 an hour. So if I was trying to get somebody to come work at Carter Construction Company and say, hey, the average person makes $18 an hour. But with the weighted mean, we realize that's not really true because I have so many making $16.50. What if I only had one person making $16.50, one person making $19 an hour, and everybody else making $25 an hour? Well, my average changes. It's not those 3 that are weighted equally. They're now weighted differently. So for this example, I have, make sure we're still recording, $16.50, I have 14 that are paid at that rate, 10 at 19, and 2 at 25. So if I told somebody that the average was about $18, $19 an hour, and they come in and there's more of a probability that they're going to be making this $14 an hour, they're going to be disappointed. So I want to make sure that the weighted mean reflects that. So here, 14 times 16.50, 10 times 19, and 2 times 25, divided by, again, I'm adding up the total that I have, 26, and I come up with a number that's just going to be a little different. Sometimes it's higher, sometimes it's lower, sometimes it's right on the mark. But you just need to know how to calculate that. Another way I could have done this, which would have taken longer, but it's the same thing, I could have added $16.50 14 times, $19 10 times, and 25 2 times, and divided by that 26. It's the same concept. The median is that midpoint number in your data. If I sort everything from smallest to largest, it's the middle number. If I have an even number of data set, then it's going to be the average of the 2 middle numbers. There is only one average and there is only one median. Only one. Mode, you can have 15, you can have 0. It can have any number. So when I ask you on that online test and then in class, number of means, number of modes, whatever it is, that should be an indication that I'm only looking for one median and one average. So again, it's going to be unique to the data. It's not affected by extremely large or extremely small data sets, and therefore is a very valuable measure of central tendency. Central tendency where the data seems to center, and it's not affected by those really large or really small numbers. And I'll give you an example. It can be computed by open-ended frequency distribution as long as the median doesn't lie in the open-ended class, which it shouldn't, meaning that if I have anybody under, I think it comes up with an example. If I have, I'll pull this up, if I have a data set that's going to be, if I'm asking age and anyone under 18, that's an open-ended data set at one side, and then anyone over age 50. That the median most likely is not going to lie in those two extremes because the median is the middle number, and that's all I worry about is that middle number. So here's an example here, and we'll use this for what we're going to do for an example. So I've come up with this median. Somebody really quick come up with what the average is. We'll do this one right here. This is more like grades. So 73, 75, 76, and 80. For this data, the median is 75.5. Okay, so the median is 75.5. What would the mean be? What's the average for this? 77? 76? I'm going with what you guys say. I don't have a calculator, and I don't know how to do this in my head. I just can't do it that fast. So this is going to be the mean. This is the median, and we'll talk about mode in a little bit. But let's say that these are grades, and my dean comes to me and says, I want to know how you guys are doing in your class. And I say, oh, the average student makes a 75. The median tells me it's about a 76. Those are kind of low, but you know, hey, he's saying first test, no big deal. Now I have this student who comes in and makes a 0. So now I have 0, 73, 75, 76, and 80. What is now my mean? What is it? 60.8. What is my median? My middle number out of these. 75. So my median didn't change, but my mean did. It was affected by this extreme 0. So if I'm going to my dean or my department head and saying, oh look, we're all fine because the average student makes a 76 and then the one person comes in and they make a 0 or a 1 and it drops my average to 60.8. Is this reflective of how most people are doing in the class? Most people aren't failing, but this one student came in and made it look like everybody was failing. So when I'm reporting this data to somebody, the best way to do it would probably be the mean or median, not the mean. Because I'm saying, look where most people, not the average. When we talk about average student, average person, average whatever, that's a term that's just taken out of context. When we talk about really the average, it doesn't necessarily reflect what's really going on. Another example, let's say that I am, well, I think it's coming up, I'll get to it. Mode is going to be the one that happens the most. Again, you can have 1 mode, 4 modes, 20 modes, or no mode. So make sure on the test, if I ask you the number of modes, this e-college system can only take certain answers, certain ways, and I have to say, here are all the ways that somebody can enter an answer, which could be an infinite number of possibilities. So I ask you on the test, not what the mode is, but the number of modes. So make sure you only enter the number of modes, not there are 3 modes, they're blank, 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 because it'll count it wrong. So make sure you're reading those problems and just entering when I say the number of modes, but that you can have multiple modes and not multiple averages or medians. And I'll show you how to do this in Excel. Now we talk about, we'll get to the range in a minute. This is skewness, which means that the data is going to concentrate on one side or the other. And and this is a good way to look at it, if all I'm given is data or numbers and I don't have a graph, then I can quickly look and see if the mean, median, mode are equal, then it's 0 skewedness, that everything is a nice normal curve, and then mode, median, and mean, if one is bigger or smaller than the other, then it tells me if it's negatively or positively skewed, which we'll get into in later chapters. The geometric mean, I have one example of this in the homework, and I may ask you a question 1 on the test, but this is not anything we're really concentrating on. And this is where you need your scientific calculator, because you have to take this to the nth root. If you're talking about 2